You look behind a massive commercial display or, a high-end home theater projector, and you just expect to see a mess of cables.
Oh, yeah, total digital spaghetti.
Right. But when you step into the world of multi-screen networks and try pushing a 4K video signal across a massive building, standard copper wiring simply, well, it collapses under the weight.
It really does.
So today, in this deep dive, we are tearing down the hidden architecture behind those flawless screens. We're looking at how specialized gear actually functions. Specifically, we're looking at the Celerity UFO-DVI-RX Universal Fiber Optic Receiver from HDTVSupply.
Because, I mean, traditional copper relies on electrical pulses. So as the physical distance between your video source and your display increases, you get all this electrical resistance that degrades the signal.
And ambient electromagnetic noise just distorts it entirely, right?
Exactly.
Okay, let's unpack this a bit. Standard cables are basically like trying to shout across a crowded room. The further away you get, the more garbled the message becomes.
Yeah, that's a good way to put it.
But swapping to a fiber optic connection is like a dedicated bullet train for your video signal. And this one uses this specialized MPO fiber optic plug, right?
Right, it's designed for high-density data. It's built specifically for maximum bandwidth and distance needs in both commercial and residential DVI projector installs.
So why is distance such a critical factor for DVI specifically?
Well, the demand for maximum bandwidth over long distances is exactly why HDTVSupply highlights this specific fiber optic solution. I mean, they have 25 years of experience and over 10,000 positive reviews.
Oh, wow, that's a lot.
Yeah, so they know what they're talking about. They offer these specific lengths from a 3-inch pigtail up to 6 feet and 20 feet. Because managing that physical gap without introducing any signal degradation is, well, it's the entire objective.
I get that light solves the physical distance issue. My hangup is HDCP 2.2.
Ah, the copy protection protocol.
Right. That heavy mandatory protocol for modern video. When you're pushing protected WUXGA, which is that ultra-wide 1920 by 1200 resolution, or even full 4K over these long runs, timing is usually where copper completely falls on its face.
It totally fails.
So does swapping to an MPO fiber plug just, I don't know, magically bypass that handshake latency?
Well, no, it doesn't bypass it. It actually accommodates it perfectly.
Wait, really?
Yeah. HDCP 2.2 requires constant, microsecond perfect two-way communication between the source and the display to make sure the content isn't being pirated.
Okay.
On long copper runs, that timing drifts, the handshake fails, and your screen just goes black.
Which is a nightmare for commercial setups.
Right. But because fiber optic pulses travel at the speed of light with near zero latency, that cryptographic handshake stays perfectly synchronized over massive distances.
That makes total sense. And looking at the Celerity unit we're dissecting today, you can actually see the premium for this tech dropping.
Oh, sure.
Like, this specific receiver went from $260 down to $189, and it's backed with a 2-year warranty. It's really transitioning from a niche luxury to standard infrastructure.
The accessibility is definitely improving. But the physical requirements of the hardware itself, they remain incredibly strict.
Actually, speaking of those physical requirements, something about the setup feels a bit contradictory to me.
How so?
Well, here's where it gets really interesting. We're using a single hyper-advanced fiber cable to push 4K data with light, right?
Right.
Yet the text specifically notes that the receive end requires a separate USB-A power LED. If this fiber cable is doing all the heavy lifting, why do we need to plug it into a standard USB port just for power?
Because the text explicitly dictates the UFO receive end for DVI includes that USB-A power LED, and that the UFO system component must be used with the UFO cable.
Okay, but why?
Because you have to completely decouple the concept of data from the concept of electrical power. This really demonstrates the complexity of high-end AV. Fiber optics are phenomenal at transmitting massive bandwidth using photons. But I mean, light doesn't carry the electrical voltage needed to physically power the microprocessors inside the receiver head itself.
Oh, I see. So the receiver is translating light back into electrical signals for the display, and that act of translation requires raw electricity.
Precisely. Managing massive data bandwidth and physical device power are two completely separate requirements in this system. You have the UFO fiber cable handling the massive data payload, and the USB-A LED acting as the literal life support. So
it just keeps the conversion chip awake so it can capture those photons and turn them back into a 4K image?
Exactly.
So for you listening, the real takeaway here is that this $189 receiver is the unsung hero keeping those massive 4K commercial screens running smoothly over long distances.
It really is.
Which leaves us with a wild thought to chew on. If fiber optic cables are the ultimate solution for our current maximum bandwidth 4K issues right now,
Which they are.
what happens when display resolutions inevitably push beyond 4K and 8K? Will fiber remain the final frontier for video transmission, or will we eventually hit the speed limit of light itself?
That's a huge question.
Something for you to ponder the next time you marvel at a massive digital display and wonder about the hidden architecture keeping it alive.